guys, welcome back to my channel. So this is today's first video and today I'm gonna upload only one video. So today we are gonna start physics, which is turning effect of force and movements and equilibrium and center of gravity. Okay, so this is just a small diagram. So let's move ahead. First of all, what is turning effect of force? See, a force that causes an object to rotate about a fixed point. I have taken an object. Wait a minute. Yeah. So this door here is fixed to the hinges. Here it's fixed to the hinges. And when I open this door or close this door, it rotates about the hinges. So this is called rotation or rotational motion. Okay. So next. Explanation: when a force is applied at a certain distance from a pivot, it creates a turning effect. This is commonly observed in everyday activities like opening a door or using a wrench. So I didn't have a photo of a wrench, so I had showed you. I've shown you this. So these are the hinges where the door is attached, and if we apply force here somewhere, it rotates in this direction. Okay, the door rotates like this when we apply force. Okay, so this is called turning effect. Opening a door, steering a wheel, using a wrench. Importance: understanding turning helps in designing stable structures and efficient machines. Okay, so next, moment of force. See, moment of force, you can call it as torque, and so the definition of moment of force is the turning effect of a force about a pivoted point. So wait a minute, I'll show. See, now this thing is pivoted here. Okay, this thing is pivoted here. So when I rotate this in clockwise or anti-clockwise direction, or when I rotate this like this screw, when I rotate it in this direction and movement is in this direction, so the distance between the pivoted point and the effort or the force, the distance between the pivoted point or the force, this is called, this distance into the force applied is called as torque. This distance into the force applied is called as torque. Okay, more the distance, less the torque. So I'll give you a short form for this: P D F, perpendicular distance into force, PDF. This is a short form for movement or torque. So SI unit of movement is Newton meter. How? The SI unit of force is Newton, the perpendicular distance SI unit is meter. So therefore you get Newton meter. Remember, when you write it, so here it should be small n, I forgot it. Here small n. This should be like this, but here I have to write small n, and CGS unit is dyne centimeter because the CGS unit of force is dyne and the CGS unit of distance is centimeter, so it's dyne centimeter. Factors affecting: magnitude of the force. More the force, less perpendicular distance is required. Less the force, more perpendicular distance is required. So if the force decreases, the perpendicular also, and if the force and perpendicular distance decreases, the moment decreases, or if both increase, the moment also increases, and the angle at which force is applied. So mostly you have to apply force in 90-degree angle. If you apply in any other angle, there may be a variation in the direction of movement. And applications: tightening or loosening a bolt with a wrench, using a crowbar for a leverage. Okay, so next, examples of movements. Common examples: door, pushing a door; steering wheel, rotating a car steering wheel; bicycle pedal, applying force to a pedal to rotate it; seesaw, a child playing on a seesaw; screwdriver, turning a screw. Real life importance: helps in designing efficient tools. Okay, I think you know all this. So I'm not making in detail videos. I'm making videos for quick revision during um, any slip test time or anything. You can just watch my video for quick revision and go write your test, because I know what ICSE board will give and I'm making mostly on those topics. Okay, so pushing a door, rotating a steering wheel, turning a driver, turning a bike, um, Force a seesaw, two people balancing a seesaw, scooter turning a screw. Okay, next, clockwise and anti-clockwise movements. So what are clockwise movements? See, when this rotates according to the clock, or when something rotates in the order of the clock, that is known as clockwise movements. And clockwise movements are always negative movements, anti-clockwise are always positive. Okay, so force causes rotation in clockwise direction. See, when a force causes rotation in a clockwise direction, that is called as clockwise movements. Anti-clockwise movements. Force causes rotation in anti-clockwise direction. Okay. Balancing moments. If a system is balanced, the sum of clockwise movements equals to the sum of anti-clockwise movements. This point you learn ahead in detail. I'll teach you. It's in the other slide. A seesaw with force applied on both sides. Example. Okay. Next. Equilibrium. So I said you just now. I'll teach you. See. No net force acting on the body, meaning the body remains at rest or moves with constant velocity. When there is when there are two equal and opposite forces acting on a body, the body either remains in rest or it still moves in the constant velocity with no change. Okay. Rotational equilibrium. Sum of clockwise movements is equal to sum of anti-clockwise movements. Example, a balanced seesaw. Real world example, a uniform beam supported at both ends with equal loads on both sides. See, this is a balanced real life example. So weighing, this is a weighing scale, this is balanced at two sides. Okay, this is balanced at two of the sides. Okay, next, principle of movements statement. For a body to be in equilibrium, the sum of the clockwise movements about a point must be equal to the sum of the anti-clockwise movements. Okay. Experiment using a meter rule suspended by two spring balances with slotted weights. Mathematical representation, sum of clockwise movements is equal to sum of anti-clockwise movements. Okay. You remember this statement, it's very important. There may be a question on this statement. You remember it or take a screenshot of this statement right now. Okay, next, this is a diagram of a meter rule suspended. So here are the weights suspended to spring balances. So when all these weights are equal and equal to these weights, the this whole balancing or meter rule will follow the principle of movements, where the sum of this is anti-clockwise movements, this is clockwise, sorry, this is anti-clockwise movements, this is clockwise movements. 1 minute, I'll erase this line so that you guys know. Yeah, next, so sum of this and sum of this are balanced. If this both are balanced, or if the weights of these are balanced, the moment of force, see, the here taken 5 Newton weight and take this centimeter to be 1 2 3 4 5, so 25 centimeter. So here you are gonna get this is 0.25 meter, 5 into or 25 5 is 125, 1.25 Newton meter. Okay, this is 1.25 Newton meter. So if you take even this as 5, it goes by 10. So this you're gonna get 35 5 how much? 2, oh no, wait. 175, 1.75 Newton meter, and this goes by 10. So here you are gonna get 1.85 Newton meter, and same here. But here there's a change because here the weights are more heavier than here. Okay. So let's move ahead. Simple numerical problem. Moment. Problem. A force of 10 Newton is applied at a perpendicular distance of 2 meters from the pivot. Find the moment of force. See, moment of force, as I said you, P D F, force into distance, 10 Newton into 2 meter, this gives us to 20 Newton meter. Concept check. What happens if the, so I'm gonna give you a question, answer me in the comment section. What happens if the force is doubled? What happens if the force is doubled? Okay, I said you before, force and perpendicular distance are inversely proportional. So stop the video right now, comment the answer, then I'm gonna tell the answer to you guys. I'll give you a timer of 10 seconds. Start it fast. Yeah guys, your time's up. So when the force is doubled, the perpendicular distance decreases. So here 10 Newton gives you 2 meter, but these are inversely proportional, right? So 20 Newton decreases this by 1. Okay, this becomes 1 meter. So you get this same answer, but here the distance is decreased by increasing of force. But if you increase the distance, the force is decreased. See, how does changing the distance affect the force? So here, if you increase the distance, the force is decreased. So now if I make it 4, the distance becomes 5 Newton. Okay, so I think you guys understood. So let's move ahead, and this is just a diagram showing the same problem here. Just watch it. Yeah, center of gravity, this is the main topic. There may be diagram based question on this topic. Definition of center of gravity: the point where the entire body of the weight of body appears to act. So this is a circle here. Take the center from all sides of this circle or this screw and it acts here. So the center of gravity of this point is here. When you hold it there, the whole object is balanced in the same line or same same size, sorry, same line. Okay, here even for this ring it's the same, it is balanced in this point. And for ball, I think you all have seen so many footballers or basketballers keeping the basketball on a single hand and rotating. That's because of the center of gravity of the basketball, which is at the center. They hold it right at the center and they rotate it. And even sometimes I have seen people holding books at the center by one finger and rotating those books, cardboards, etc., etc. And the center of gravity for this triangle is where all the 3 points of it meet. See, one, next two, so and this meets here. So my diagram is wrong, but the center of gravity of this thing is right here. Okay, and for this thing it's a straight line, the center of the straight line which is here. So this is the center of gravity for this thing. Okay, next, every object has a specific point where all its weight is concentrated. If an object is supported at CHD, it remains balanced. Example, center of a uniform rod, center of a circular disc, it's shown here. So let's move ahead. Center of gravity for regular and irregular bodies. See, center of gravity for regular and irregular bodies. Regular bodies, sphere, center of gravity at the center. Wait, I'll see. No, okay. Rectangle, center of gravity at geometric center. See, if you take a rectangle, what is geometric center? Where two of its diagonals meet. Here is its geometric center and the center of gravity is here. So the center of gravity of a book which is in a rectangle shape can be balanced by holding it where its diagonals meet. Okay, cylinder, a point middle at its axis. Okay, wait. See, take a cylinder, a point here, somewhere here at its axis is known as its center of gravity. Okay, irregular bodies found using the suspension method. See, this is a irregular body now. Okay, this is found by using suspension method. They put 4 holes here, and from those holes they draw equal diagonals, and where those meet, that's the center of the gravity of that body. Okay, next. Example, cardboard cutout hung from different points helps in designing stable structures like buildings and bridges. Okay, summary, and now I'm gonna end the video. Key takeaways: turning force creates rotational motion, movement torque depends on force and distance from pivot, equilibrium occurs when opposing movements balance, center of gravity determines an object's stability. Understanding these concepts is essential in engineering, mechanics and daily life. Okay, this is a balancing beam, and thank you for watching, and I have written down the possible questions from this chapter. I request you all to answer these questions in the comment section. I'll check who has answered, and the next video I'm gonna shout out to the first 3 people who have answered correctly. So take a screenshot, or I'll pause the video and write down in a book and answer these. Don't use Google, just answer on what you have read. Okay, thank you guys. Bye bye. See you in the next video.